Welcome back, everybody. And now in part 4, we're going to take all of those concepts that we've been talking about up to this point, and now we're going to start actually working with chemical equations and balancing chemical equations. Before we can start applying some of those terms for molar mass and some of those conversions that we were doing into actual chemical reactions, we need to first look at those reactions and make sure that we've balanced them off so they're equal, they're actual representations of what's actually going on in the reaction. So we have a quick introduction to how we write chemical equations, because again, this is a new language that we need to learn. So when we write a chemical equation, we have some conventions here so we can express the information in very similar ways so we understand what we're talking about, what we're all talking about when we write different equations. So the left side of the equation is always our reactants with an arrow that means going to, converting our reactants to our products on the right side. The letters that are in parentheses at the end of each compound, that's the physical state. Solid, an S, a liquid, an L, gas is G, or if it's dissolved in water, it's what we call an aqueous. So like we give that an AQ symbol. So that's very important to tell us what phase the compound is in. And then any numbers in front of the compounds are what we call a stoichiometric coefficient. How many molecules are present? So in this example here, when I react methane with oxygen, I take one molecule of methane, combine it with 2 molecules of oxygen, and what I convert all that to is 1 molecule of carbon dioxide and 2 molecules of water. So these molecules, the stoichiometry, the numbers in front, tell us how many molecules are present. Again, the subscripts behind, like in methane, the CH4, tells us how many atoms are in the molecule. So we want to be careful when we look at the coefficient versus the molecule itself. Okay. So this law of conservation of matter. Matter is neither created nor destroyed. So atoms are conserved in a chemical reaction. And all that really means is however many atoms I have on the reactant side, I have to have the same number of atoms and the same identity of atoms on the product side. So I can't change atoms. I can't take hydrogen and all of a sudden make it into carbon. So if I've got 4 carbon atoms on the left side, on the reactant side, I've got to have 4 carbons on the product side. I'm just rearranging their locations. That's all I'm doing in chemistry, is just rearranging the molecules and the atoms that I have into new forms. So I have to make sure however much I start with, I have to have the exact same when I finish, just in different locations. That's what the law of conservation of matter is really all about. So here we see I can just make a list on the reactant side. I've got 2 carbons, 6 hydrogens, and 7 oxygens. And then when I look on the product side, I have 2 carbons, 6 hydrogens, and 7 oxygens. So when the numbers are the same on both the reactant and the product side, I say that this equation is balanced. So here's an example of a balanced chemical equation. And in order to balance the chemical equation, as we'll see, what we can do is we can change the coefficients in front. In this example, the 3 in front of the oxygen, the 2 in front of carbon dioxide, and the 3 in front of the water, those can change. What we can never change are the subscripts that make up like the 2 in oxygen, or the 2 in the water molecule H2O. Those we cannot ever change, because changing those changes the molecule that I'm dealing with. So we can't do that. I can change the coefficients in front, and that's what we need to work with in order to balance these chemical equations. So we're going to go through a process to balancing chemical equations, 5 steps that we go through. And then once you do this, this will become a very, very simple, quick process. In most cases, balancing chemical reactions is a very, very fast process. As you see in some examples, the ones that we're going to talk about, they're going to be a little bit more challenging, is when we're dealing with combustion reactions. That in those cases, the coefficients can get very large very quickly. So balancing chemical equations. Step 1, we begin with atoms that appear in only one compound on the left and only one compound on the right. Those are the easiest ones. It's in one spot on the left, one spot on the right. Easy to balance off. If an element appears in more than one compound in either the reactants or the products, we're just going to wait on that. We'll do that one at the end. If an atom occurs as a free element, we're going to balance that at the very end, because that's the simplest thing to do, and it takes no effort at all. And again, only coefficients change. Never change the subscripts within the chemical formula. And then the coefficients are always the lowest possible whole numbers. No fractions, no decimal values. All right, so let's use these 5 steps and go through some examples of balancing chemical equations. So the combustion of magnesium, burning magnesium in the presence of oxygen. So I start with magnesium plus oxygen going to magnesium oxide. And the first thing we would want to do is from this base equation with no coefficients, or the coefficients are always or 1. If we don't write a number, the 1 is understood. We just add up how many atoms we have on the reactant side, 1 magnesium, 2 oxygen, and how many we have on the product side, 1 and 1. So we are not balanced. They're not the same on both sides, so we need to change that. So the magnesium we're going to leave alone because that's 1 to 1. It's the oxygen that we need to change. So in order to get that to be the same, I'm going to leave the reactant side alone. I'm going to add a 2 coefficient in front of the magnesium oxide on the product. Now we'll check our numbers again. I've got 2 magnesium, 2 oxygen on the product side, 1 magnesium, 2 oxygen on the reactant side. So I'm still not quite that balanced in terms of oxygen, but not in terms of magnesium. But because magnesium is in its elemental state, we save that one for the end. That one's easy to balance off. I just need to put a 2 coefficient in front of the magnesium on the reactant side. Now when I add this all up with this, I have a balanced chemical reaction. Both reactants and products have the same number of atoms present. All right. This is a straightforward, simple example, and the reality is most chemical equations are going to be this simple and this straightforward. We're going to look at some that are much, much harder just to give us some practice and to get comfortable with this process. So we need to, before we can really work with the equation, the first thing we always want to check is it balanced? Do I have the same number of atoms on both sides? So let's look at this one. I have 3 carbons, 8 hydrogens, 2 oxygens initially on the reactant side, and 1, 2, 3 respectively on the product side. So again, not balanced. So let's look at this, and now let's change the number of carbon dioxide. Let's look at that because that's a place where we can easily balance this off. So I've got 3 carbons on the reactant side, so this will give me 3 carbons on the product side. Of course, that also changes the number of oxygens. So instead of 1 carbon, 2 hydrogens, 3 oxygens, I now have 3, 2, and 7 that I need to work with. So let's go to a clean screen. So this is where we left it. So now let's put a 4 coefficient in front of the hydrogens. That's going to balance off the hydrogens. Now I've got 8 hydrogens on the reactant side, and I've got 8 hydrogens on the product side. So we balanced the carbon, we balanced the hydrogen, it's just the oxygen that's left. And I can see I've got 2 oxygen on the reactant side, 10 on the product side. Very quickly I can balance the oxygen by putting a 5 coefficient in front of the O2 on the reactant side. When I do that, now double check all my coefficients, 3, 8, 10 on the reactant side, and I have 3, 8, 10 on the product side. Here's an example of a combustion reaction. Oxygen is always going to be a reactant in a combustion reaction. I'm going to produce usually carbon dioxide and water on my product side. And here's an example where my coefficients are relatively large. Usually coefficients are 1, 2, maybe 3. To get a 4 or 5, that's more on the unusual side. But for combustion reactions, that's pretty common to get some much larger coefficients. So now we've gone through and balanced this reaction off. So take a minute and answer this question. Go through and figure out what are the proper coefficients for this combustion reaction. Okay, so going through the procedure, we're going to see that C is the correct answer. Coefficients are 1, 3, 2, and 3 respectively for our components. Okay, so let's look at that question. So if you didn't get that one correct, so let's go through how we actually got to the correct answer on this question and balance this off. So let's start off with just getting an initial assessment of how many atoms that I'm dealing with. So on the reactant side, I've got 2, 6, and 3. On the product side, 1, 2, and 3 respectively between carbon, hydrogen, and oxygen. I'm going to choose to balance off the carbon first. I can do that simply by changing my coefficient on carbon dioxide on the product side from a 1 to a 2. So we'll do that. I haven't changed the numbers of reactant atoms, but my product elements now become 2, 2, and 5. So I balance off my carbons. The next thing that I'll balance off is the water molecules, or the hydrogen, and I'll do that from the water. So I need to have 6 hydrogens from the reactant side, and I need 6 on the product side. So I'll do that by changing my coefficient for water from a 1 to a 3. So now I have 2 carbons, 6 hydrogens, 7 oxygens on the product side. So I balance off my carbon and my hydrogen. I need to balance off the oxygen now. And I'll do that by changing my coefficient of the O2 on the reactant side. Here I'll go from a 1 to a 3 as well. Now when I double check my totals, I've got 2, 6, and 7 on the reactant side and 2, 6, and 7 on the product side. So here I've gone and balanced my chemical reaction. Okay, I'm going to leave things here. This gives you some examples of how to balance these reactions. There's plenty more in OWL, and again, you can do these as many times as necessary in your homework until you get comfortable with this process. Thanks so much, everybody. Take care.